In example 5, we're going to be solving a dependent system, and we want to solve the systems of equations. So we're going to perform row operations on the augmented matrix to try and achieve row echelon form. So the first thing we want to do is write it in augmented matrix form. So we have 3, 6 as the coefficients of x, 4, 8 as the coefficients of y, the equal sign is our line, and then we have the constants 12 and 24. Now if you notice here, what can we do to eliminate this 6 before making the upper left-hand corner a 1? Well, if you take -2 and multiply it by 3, which is going to give you -6, and if we add it to row 2, then it's going to give us 0. If we take -2 and multiply it by 4, it gives us -8. If we add it to row 2, it's going to give us 0. If we take -2 and multiply it by 12, we get -24, and if we add it to +24, we get 0. So when you get all zeros now in the last row, the matrix ends up with all zeros in the last row. So you have 0y is equal to 0. Thus, there are infinite number of solutions, and the system is classified as dependent because what it's saying here is that this represents a true statement. And if it's a true statement where 0 is equal to 0, then we know it's dependent. And now what we want to do is to find the general solution, we return to one of the original equations and solve for y. So the original equation was 3x plus 4y equals 12. And if we solve for y by subtracting 3x to both sides and dividing each term by 4, so that means the y value represents 3 minus 3/4 x, and then the x value is just going to be x.